Hey everybody, let's spend a little bit of time looking at question 21.9 in Brown, LeMay, Burston. Okay, so this is a seemingly straightforward question, but it never hurts to go over some of the more straightforward questions. And so here for part A, if I can get that down. So for part A, okay, it says we want just the number of protons and neutrons, which I guess becomes important when we're dealing with nuclear reactions. Remember, nuclear reactions are reactions that happen with the particles in the nucleus, which are protons and neutrons. So it stands to reason, I guess, that we know how to determine the number of protons and neutrons given a symbol. And so here, for A, the number of protons, P plus, is equal to the atomic number, which in this case is the bottom, which is 24. And now we subtract, because the top number is the mass number, and so we take and we subtract 24 from 56, and we get 32. Okay, and so that's the mass number. Okay, we shouldn't look on the periodic table and use the atomic mass. Remember, that's the average atomic mass, and that's not the right number. And so here we have thallium. Okay, now in this case, for thallium, we have to look at the periodic table and look at its atomic number. So I'm looking at a periodic table. Its atomic number is 81. Okay, and so the number of protons there is 81. And remember, the number of neutrons plus the number of protons equals the atomic number there, or the mass number there. So the number of neutrons must be 112. Okay, and then C, argon 38. Well, again, let's look at the periodic table. Argon's atomic number is 18. So that means that the number of protons is 18, and that means the number of neutrons, 18 plus what equals 38. That's what I always say in my head, like back here, 24 plus what equals 56. Okay, 81 plus what equals 193. And so that means the number of neutrons is 20. Okay, so that goes over 21.9, and have a great time.